So I think we can start. So hi everybody, my name is David, and today I'll be talking about how you can use principles on functional programming in your React application. But first, just a quick survey. Who uses React on a regular basis? Raise your hand, please. Cool. So many React developers. And a second question, who doesn't like lawyers? Raise your hand, please. Oh, it's too bad. So, why am I asking? 2 years ago, I worked as a lawyer specializing on European Union law. Today, I work as a front-end developer. So I hope you don't hate me now. Recently, I came back to blogging, so if you are interested, you can check my Twitter, my blog, codinglawyer.net, or my Medium account, and you can get all the code. We are going to use it today on my GitHub account. Currently, I work at Ataccama, international software company focusing on data quality. Currently, we are developing a new, pretty large web application with front-end built in React. And developing this application, we are using principles of functional programming. And this is the topic I'm going to talk about for the next 60 minutes we are going to spend with each other. So, because we are all programmers here, even me, let's start with some code. Now, the code I'm going to show you now, you don't need to remember it, you don't need to know how it works, because we are going to work with the parts of this code during the whole presentation. So here we have just array of Star Wars characters. It will be our mock data for the most examples. You see we have an object, we have a name and site to which the character belongs to. Then we are passing this array to the filtered list according with the prop default state, which is set to the dark. Now here we have a really large component. You know, it's really large. It provides us with state and state handler, so we can change the state. It also filters the Star Wars characters according to the site, which is stored in the state of the component. And then it renders the UI. So it does so many things. It takes care for the logic, for the UI, and really this component is hardly reusable, because you cannot just cherry pick a piece of functionality from it and use it elsewhere of your application. You just need to use the component as it is, or don't use it at all. Now, in the end of my talk, we'll be able to transform this not reusable piece of code into reusable code using principles of functional programming. Now you can see even Boromir agrees with me. So, because we are going to talk about functional programming in React, we should spend a couple of minutes talking about principles on functional programming in general. So just a very brief introduction. So the idea of functional programming is that you want to decompose your program into a simple function and then combine them to form an application. So functional programming is all about functions, preferably small functions. So you want that function takes care or is responsible only for a single task. As you all know, in React you can use functions as any other values. You can pass them as a parameter to a function, return them from a function, and function that returns or creates new function is called a higher order function. So in our example, higher order function is create adding function, because it takes number parameter and it creates new function that is waiting for an array to be passed. So we pass the number, we get the new function, and we store it as a numbers plus one function. So the function is waiting for array now, and we pass the array of numbers, and each number array is increased by one due to the mapping function which is inside our function, create adding function. So if you take a look at the syntax, you know, we are basically telling JavaScript engine what we want to do, that we want to map array of numbers. See, this code is pretty self-explanatory. It's called declarative. And functional programming, it's all about this type of code, about declarative code. Now, as a functional programmer, you want to avoid side effects in your functions as much as possible. This means that your function should not have any side effects. That means that it should not affect the outer scope, its outer scope. And functions without side effects are called pure functions. Another feature of pure function is that it returns the same output given the same arguments. We will see an example in a little bit. If you want to write pure functions, you also don't want to mutate your data. This is called principle of immutability. That doesn't mean you don't change your data. It just means when you want to change your data, you just don't want to mutate them, you just want to return a new value. Now, in JavaScript, values like arrays and objects are mutable. So what we can do is that we just consider them as immutable, that we won't mutate them. And this way you can avoid common mistakes such as mutating object that was passed as a parameter to a function. Now let's take a look at an example of pure function and impure function. Here, pure function is what we've already seen. You see, we have an array of numbers at the beginning. Then we apply it to the function, passes as a parameter to a function, and then at the end you see numbers. Is it a still array? Nothing's mutated. So this is a pure function, no side effects, no mutation. Now, if we check this one, this is an impure function. Again, at the beginning, we have an array of numbers, and then we have function. But this function, it's a loop that mutates our array. So at the end, if we print the numbers, in the end, we mutated the array. And we want to do that because this can make a lot of mess in our code, and we don't want to do this, especially in the functional programming. So now we know that we want to use simple pure functions. However, what if we needed a kind of logic that cannot be stored in the simple function? Then we need to find a way how to combine several functions together. And we can use composition for this. Composition simply means that we pass the result of one function as an input to a second function, its a result as an input to a third function, and so on until all functions were called. Here's a silly example. We have a number and three functions: increment, decrement, multiply. And what we are doing is that we're wrapping them inside each other. So this is so-called compound function. And we pass our number to the last multiply function. So it works pretty easily. We pass the number to multiply, we get multiplied number, pass it the result to decrement, we get another number, and pass it to increment, and we get the final result, which is print as 32. So the true power of these basic principles is you can see it if you apply them together. So you want your application to be composed of simple pure functions that consider their data as immutable. That means that they don't affect their other scope, and you can use them as they are, or you can combine them with other functions using composition to get the more complex behavior. So you will end up with simpler reusable functions that can be composed together. So this was just a quick intro to functional programming, and now let's go to React. So let's take a look at how we can use our principles in React. So, as we all know, React applications are composed of components. But what's a component? If we just take a quick look at a simple component, here's a class-based component and functional component. You will know that class is just a syntactic sugar for functions, and functional component is basically a function. So React components are a function. It is a function that takes props object and return the tree of React elements. Of course, it can also return a component, but we will talk about it later. Now, so not only that React is a composition of components, it's a composition of functions, and that sounds awfully like a functional programming, doesn't it? Now, let's take a look inside a React component. React components are basically composed of logic and UI. Now, you don't want to write all your components as a combination of these two principles, of these two things, because you would end up with dozens of components that are probably able to be used only for a single use case scenario. So what can you do instead? You want to separate these two concerns, logic and UI. And you can do it, for example, that you divide your components to smart and presentational components. Presentational component will take care only for the UI. It doesn't care about logic. So most of the time it will be defined as a functional component, because functional component is just a render function. On the other hand, smart component will take care for all the logic, for all the event handlers, API calls, data formatting, and it will be often defined as a class component because you will often need that class-specific behavior such as lifecycle and state. So you want each of these components to be defined in a way that you can reuse it throughout your app, and in a way that it should be responsible only for a single task. By single task, I mean UI or logic, and you should try to minimize the combination of both in the single components if it's possible. Now let's take a look at some examples. Here we have a display list class component. You can see we have a state and render function. We store a list of Star Wars characters in the state, and then we just display it to the screen, so pretty simple. Let's take a look at its functional version. We don't have a state here, so we are passing the list of Star Wars characters as a props to the display list, and display list just takes the props and displays it to the screen. Now, if we take a look at this, our display list component, you see it takes care only for the presentation. There's no logic, so it's really easy to reuse it throughout the application. So if you need to display a list of Star Wars characters elsewhere in your application, you can use this our display list. So this is a good start. Now, if we check again the display list function, what it does, it takes props, in our case list, and renders them to the screen. So it doesn't have any side effects, it doesn't mutate anything, so it's pure function. So not only that React application is a composition of functions, it can be also a composition of pure functions. And since we want to use principles of functional programming in our code, we want to define our components as functional as possible. And that way we would be able to use different techniques of functional programming in our code. For example, higher order components. Now, let's again take a look at our functional component, reusable presentational display list component. So now it only displays all the Star Wars characters. But what if we wanted to display only Star Wars characters belonging to a particular site? Well, the most simple solution would be just place the logic directly inside the display list component. See, we renamed our display list component to filtered list because it now not only it displays characters, it only filters them. So we move logic here and we pass a new site prop, you can see here, and then we filters them according the list according to the past props. However, the problem is that this component is hardly reusable because now, if we wanted to display elsewhere in our application list of Star Wars characters unfiltered, we cannot use this component. We would need to define a new component. Furthermore, if we wanted to reuse the filtering logic, again, we need to define a new filtering logic somewhere else. And we don't want to do this. Fortunately, we can achieve the same result using a more elegant and declarative solution. Let's check it out. Here we renamed our display list to render display list to make it obvious that it's just only render the UI. Then we have a new function with filter props. We are going to talk about it later. And we have a new component filter list, which then we render in the render function and pass props to it. So let's take a look how the filtered list, our component, is created. First, we pass render display list, our presentational component, to the with filter props. We can check the with filter props. With filter props is waiting for the component. That's the render display list, and we get back a functional component waiting for the site and list prop. So we then store this new component inside filtered list, and then we just render it and pass it the props, the site and list prop. So what happens is that our with filter props will take the list, filters it according to the site, and pass the filtered list down to the base component, that is render display list, and render display list will just display the filtered list of Star Wars characters. Now, so to simply put, what we did here is that we enhanced our render display list component with the logic from with filter props, with the filtering logic. If we take a look more at our with filter props component, we can see that it's a higher order function. It takes another function and it returns another function. In this case, in React vocabulary, we call it higher order component. just as higher order function creates a new function, higher order component creates a new component for us. So higher order component takes a component and returns a new component that renders the past one. In our case, what we did is that we pass the render display list to with filter props as the component, and we get back a functional component that renders the base component, which is our render display list. Now, what we did is that our render display list is reusable again. It does take care only for the UI. And what we did here is that we move all the logic to the higher order component with filter props and let the render display list to take care only for the presentation. Now again, higher order components enables you to enhance your presentational component by some logic. You can think of them as wrappers for your components. And the cool thing is that you can store whatever logic you want in your higher order component. We store there transformation props logic. You can maintain state or affect the presentation component rendering, and it's really powerful. Now this way you don't need to use a class component for your presentational components anymore, because the base component, the presentational component, will always take care for the UI. And if we just now again consider the distinction between presentational and smart component, again render display list, our wrap component, will always be presentational. It takes care only for the UI. On the other hand, higher order component takes care for the logic, so it's a smart one. Now, before it's almost lunchtime, let's talk about food a little bit. This is the huge, not reusable piece of code from the beginning. Now, imagine this as a meatloaf. You know, meatloaf. When you're cooking meatloaf, you mix all the meat, eggs, breadcrumbs together. You put it in the oven, and you have a meatloaf. Now, when it's finished, you cannot decide that you want to take eggs from it or meat from it, because everything is irrevocably combined. So, just as you cannot take this from the meatloaf, you cannot take the piece of functionality from the huge component we just seen. Now, to make some contrast, imagine your reusable presentational components as pancakes. Now, pancakes are pretty boring, you know, no one eats them like this. So you want to put some sweet stuff on them, you know, pour them with maple syrup or add some berries. And in React application, these decorating layers are like higher order components. So just as you can decorate your pancakes with layers, with toppings according to your taste, you can decorate your presentational components according to the functionality you want. So as a result, you can use your reusable presentational component in the different place of your application, and then enhance it by a higher order component, depending what kind of functionality you want. So I hope this helped you to understand higher order components a little bit more. If not, at least I made you hungry. So now we know that you want to make how to create higher order component. But let's talk a bit about reusability. Reusability means that you want to decouple data from your component. That simply means that you don't want your components to be dependent on the prop structure. If we check our previous example, here we have render display list component, which is what we did before is that we move the logic to the higher order component and let the render display list to take care only for the UI. Render display list is now easily reusable thanks to this. However, if we check our higher order component with filter props, you can see that it's dependent on the list and side prop, and because of its purpose, it's now really difficult to reuse it elsewhere. So we want to make it reusable, because we don't want this kind of specificity in our code. So we can do it like this. Now, this code does the same thing as the code from before. The difference here is that we renamed our with filter props to with transform props, because now it's more general. It can do a lot of things, not only filtering props. And you can see it now takes as a first argument new function. So let's see what it does. So let's check out our filtered list, our component that we are rendering in the end. First, we pass a configuration function to with transform props. Now, this configuration function will be responsible for the filtering. So this is the same function as we had before inside our higher order component. Now we are just passing it as a configuration argument. So we pass it here, and what you get back is a so-called specialized higher order component. It has a transformation function inside a closure. And to make it more obvious, we are storing it under variable configured component. And it's now waiting for the base component to be passed. So we pass render display list. We get back a new functional component that is waiting for the base props. We store this new component, this enhanced component, as a filtered list. And then we just renders it to the screen. We pass it props, we pass it side prop, list prop. And now it goes here. We will use the transformation function to filter the props, and then we pass the filtered props down to the base component, which is our render display list component. Now, if you take a look at this example, it's pretty verbose. We really don't need to store our specialized higher order component inside configured component. So what we can do is just that we write it like this. It still does the same thing, but we are not storing that configured component. Now, the idea of this higher order component is that now that you can configure it for a specific scenario. In our case, we pass filtering function, but you can pass the different transformation function in different scenarios. It's also a great feature that now if you decide you want to change this logic, you just need to change it in this one component. Now, and if we go there, see this is how it works. We have a configuration component, enhanced component. And now if we check our two components, our with transform props component and render display list component, they are both independent on each other. With transform props component don't know where is data are goes, and render display list component don't know where is data are coming from. So writing reusable components, higher order components, as well as presentational components will help you to avoid unnecessary duplication. It will also force you to write more simple functions. Now, we've talked about, we know that we should be creating reusable, simple, higher order components. But let's take a look when to decide when to define it as a class-based component or as a functional component. Now, because we want to use principles of functional programming, we want most our components to be functional. So we are doing this now with the presentational components, and we're also doing this with the higher order components. So functional higher order component just takes, you can see it here, it just takes a base component and it turns a new component that renders the base component. So it's actually, it doesn't have any side effects, it doesn't mutate anything. So it's basically, it's a pure function. But sooner or later, we will need that state, we will need lifecycle, this class-specific behavior for our presentational components. So we need to define our higher order component with classes because we can get this behavior anywhere else. So let's try to define a class higher order component, class-based. Here we defined a with simple state component. You can see it takes some default state. Is it that, again, configuration argument that will set the state of the component? And then we get the state handler that we can use to change the state. And then we just pass these state utilities along the original props to the base component. Now let's take a look how it works in action. But before, because we don't have with transform props higher order component anymore, we move the filtering logic inside our render display list component, which is now hardly reusable because of this logic. But we work just only with higher order components, so we move the logic here just for this piece of code. So if we check the filtered list component now, we can now say that again, the render display list will be enhanced by with simple state by the state functionality logic. So we can take a look how it works. We've first passed the dark string, which is configuration string to the with simple state. And when we do that, we get the specialized higher order component with the string inside the closure. And now we get back a higher order component that is waiting for the base component to be passed. So we pass render display list component. Now we get back a class component that is waiting for the props to be passed. And we store this as a filtered list. Now again, we just render the filtered list, pass it the list of Star Wars characters. It goes here to our with simple state. That will establish the state handler, and it will pass it along the original props to the base component, which is the render display list component. Render display component takes the list, it filters the list, and then it just renders to the screen the list of Star Wars characters and the button. And if you click the button, you can change the side from the light to dark. It works just like this. It's really simple. You can switch the sides. Okay. Now again, just as a reminder, we enhanced our render display list with the state logic. Now, if we take a look at our with simple state higher order component, you might say it's not a pure function because we have that impure class behavior, so that doesn't look really good. But if we take a closer look, we can see what it does, what with simple state does. It takes some arguments, and in the end, it returns a new component. So it's still a pure function because purity of a function is judged from the outside, regardless of what's going on inside. So what we did is that we hide the impure behavior inside our higher order component, which is a pure function. So we can encapsulate the impure function inside our higher order component. So whenever you need to use this class-specific behavior like state or lifecycle, you just hide it inside your higher order component. Now, if we check our render display list component, I already mentioned that we move the logic here. We have filtering logic here, and now it's again it will be hardly to reuse it. So we want that logic put it elsewhere. So how we can do it is that we need to find a way how we can combine with transform props higher component and with simple state higher order component and get their functionality to our render display list component. And we can use composition for this. Now, we've already talked about composition at the beginning, so just a quick reminder. Composition means that we pass the result of the one function as an input to a second function and so on until all functions were called. Here our example, again number, 3 functions, and we just create component function. We wrap the functions inside each other. Now, this code works, but there's a problem because the readability of this is not so good. And imagine that if we had even more functions, the readability would be much worse. So what we can use a function programming helper, a helper from functional programming called Recompose. Now, what we are doing, we don't need to wrap anymore our 3 functions inside each other. Instead, we pass them to the compose. And what compose does, it returns compound function back to us. Now, we get the compound function waiting for the value. So at the end, we just pass the value to our compound function, which we stored as a func composition. And a compose will do all the wrapping for us. It will take the value, pass it to the multiply, result to decrement, and result to increment. So just as in the case before. Now, let's compose together several higher order components. Now, we already know that we should define simple, reusable higher order components. But again, what if we need a behavior that just cannot be stored in that simple higher order component? We need to find a way how to combine a functionality from multiple components and pass it to our presentational component. And we can use it, again, composition for it. So let's take a look how we can do that. Here again, we have our with simple state higher order component. We already know what it does. It It just creates state handler, and pass it down to the base component along with the original props. Then we have a with transform props component. It still does the same thing. We pass the configuration function, and it makes something with our props and pass it to the base component. We have render display list. We already know what it does. So let's take a look at the composition. Now we have filtered list component and toggleable filtered list component. Now, filtered list component is enhanced component. You can see again we are enhancing the render display list by the with transform props logic. In toggleable filtered list, you can see that we take the filtered list, which is already enhanced, and we enhance it even more with the with simple state, with the state functionality. Now let's take a look how this really works. First, filter state. So again, we are passing the configuration function to the with transform props. It's here we get the back specialized higher order component, waiting for the base component to be passed. We passed again render display list as our base component. We get back a functional component waiting for the props. And now just you need to remember that in this case the base component is render display list. So we store this component as a filtered list. Our enhanced component is stored there waiting for the props. Now let's take a look at toggleable filtered list. Here we have with simple state we pass the configuration string. We get back specialized higher order component with the string in the closure. And it's now waiting for the base component. So we pass the filtered list as a base component. So again we are now waiting for the props. We pass. And now again, is it now good to remember that now our base component is now render display list, but it's filtered list, our enhanced component. So let's see, we store this component waiting for the props again as a toggleable filtered list. And then we render it, we pass it list with Star Wars characters, and now we now know what is happening, but just we need to keep in mind that the base component is filtered list. So it works that we establish state handler, and pass it down to the filtered list along with the list prop. Now this way we render filtered list. The props goes to our filtered list, which is our with transform props. So we take the list, filters it, and pass the filtered list down according with the functionality according with the state functionalities. And now we just we pass everything to the render display list. A render display list takes the state handler, use it in the on click, and displays the list of Star Wars characters. Now, what we did here again is that we pass our render display list component through both of our higher order components. First, our higher order component gave us transformation logic. Second component gave us state logic. And what we've just seen also is that props is the only language the higher order components can talk to each other inside composition. You've just seen that the higher order component just performs some action, and it results in the props enhancement, and then they are passed down to the component structure. Now, if you take a look again at our composition, again, this is pretty verbose. We don't need to store toggleable filtered lists in a separate variable. Instead, we can just wrap everything inside each other. You see, we are passing the with transform props to the with simple state, and so on, just as we did in our first example with the only functions. However, this component, this readability really sucks. Because now imagine if we had even more higher order components, then we have all the wrappings, all the configuration functions. It's really difficult to read this. So we can use the compose helper for this, like this. And now we just pass the higher order components to the compose function. And when we pass them, we get back a compound function, and we store it as enhance. So this is what's going on in the compose. And now our enhance function is just waiting for the base component. So we pass it just to render display list. And now the compose function will do everything for us, all the wrappings. So this pretty helps our case. Now, I would like to come back to our pancake parable. Before we were, decorating our pancakes only with a single decorating layer, single topping. We use banana or chocolate or cream. But pancakes taste much better if you use some more decorating layers. If you combine banana with chocolate, you know what I'm talking about. So, just as you can decorate your pancakes with one or more decorating layers, according to your taste, you can decorate your reusable presentational components with one or several higher order components depending on logic you want. So if you want a complex logic for your components, you don't need to store it in a single ordinary component. You don't need to store it in the single higher order component. You just store them in the multiple simple higher order components and then just compose them together. Now, till now we've just seen some custom higher order components. But this pattern is so powerful that it has been used in many React-based libraries, such as React Redux, Recompose, or React Router. And I would like to talk a bit more about Recompose. Now, Recompose contains dozens of predefined higher order components, and it uses higher order components from everything from affecting the rendering of presentational component, maintain state, lifecycle methods. So what we can do now, we can try to rewrite our composition using Recompose. Now, we don't need our with simple state component and with transform props higher order component anymore, because there are their predefined versions called with state and map props. And we also have compose function here, so we also don't need to define it ourselves. So in this case, with state is more reusable than our version because it takes 3 arguments. We pass it name of the state handler, and default state. And map props, it works just like our implementation. We just pass the props transformation function. So you can see in this example, we were able to create our composition, but we didn't need to define the higher order components by ourselves. But we can also improve this composition using predefined Recompose higher order component, because there are still some issues we haven't addressed yet. If we check our render display list component, and if we more specifically check the onClick handler, now you can see that this handler is recreated each time the render display list renders. Now, this might hinder performance of our application. Not obviously in this case, but you can have it in more complicated cases. So now the handlers is recreated each time the component re-renders. And we can do something about it. We can use with the handlers higher order component from Recompose. We add it to our composition, and now just what it does. First, it takes again a configuration argument. We pass objects of function. In our case, it's just one function, one handler called handle set state. And when we pass the props through with handlers, the inner function access the props. It takes, in our case, we take state handler and other side from the prop, and we get back the handler, and then inject it to the props and send down to our presentational component. So it goes down to render display list. We take the handle set state and set it as a click handler. With handlers, higher order component makes sure that the identity of our handler is preserved. So now this handler is not recreated each time the render display list re-renders. It's recreated only when the props changed. But with handlers, it's much more useful because in the real world example, you have much more than one handler in your component. And the cool thing about with handlers is that you can put all your handlers inside with handlers. First, they are optimized. And secondly, if anyone from your team comes to your code and he needs just to check with handlers and he see all the handlers there has been used in the component. So it's easier than just go to some big class and you need to find all the handlers. So that's pretty useful. So by providing us with so many higher order components, predefined higher order components, Recompose makes it much easier for us to make higher order component composition, and it makes much easier to use higher order components in general. Now, let's talk a bit about functional component and performance. Now, we want to have satisfied users, so we need to make sure that our applications are fast and smooth. Now, and to do this, we need to make sure that the performance of our application is well optimized. React helps us with this a lot because under the hood it implements a variety of techniques that minimize the expensive DOM manipulation. But there are still some cases where it's up to the developer to make sure that his particular implementation doesn't damage performance. One typical example is you have a component and it updates really often. And it has child component, but the update of the parent doesn't affect the child. So normally you are rendering the child again, even if you don't need to. So fortunately, React provides us, as I'm sure you know, with the should-component update method. It's available for the classes, it's inherited from the React component, and before your components re-render, this method is called, and you can compare previous state, previous props with the current state and current props, and then to decide if you want to re-render your component and all of its children or not. Now, if you don't want to define this manually, you can extend your class not by React.component, but by React.peerComponent, and you have this automatically. Now, let's see it in action. Here we have our render display list component, and we created a new heading class component. Now, we place the heading inside render display list. So what heading does, it just displays some text, it just displays title, and we pass it a title prop. Now, title prop is static, it doesn't change, it never changes, so we don't need to. So whenever the render display list re-renders, that's when you press the on-click button, we don't need to re-render heading component because it never changes, because the prop is still the same. And this code works just like that, because we extended our heading component by React.peerComponent, and we have a should-component update method under the hood. So whenever the render display list component renders, the should-component update inside heading component is called, and previous title prop and current title prop are compared, and because they are all still the same, they never re-render. Now, you might be thinking, why are we defining our heading component as a class? Because it's just a pure function, so it should be a functional component, obviously. But the question is if we can get this optimization behavior also for the functional components, because should component update comes from the React component, and this is accessible only in classes. We can create by ourselves higher order component, or take a predefined one, pure higher order component from Recompose. Now, we defined the heading as a functional component, and the only thing we need to do is just that we wrap it with the pure higher order component. This way, the heading works just the same as the previous example. We have should component update thanks to this higher order component. So thanks to this pattern, we get the same benefits for the functional components as are available for the classes. So we don't need to define classes just to get this performance benefit. Now a little bit controversial topic. You might be saying there are different alternatives that we can achieve the results we achieved with the higher order components using different patterns. So at the beginning we saw this one. We already said it's hardly reusable, so this is not a good alternative. However, there's a better alternative called function as a child, or render props these days. Now, first let's take a look at example when we use it only with one enhancer. So here we have a transform props component that was our former with transform props, and now it's not a higher order component, it's the only component. But here you can see that at the end it calls its child with the props, so it presumes that its children is props, is function. Sorry, its children is function. Then we have a display list, it's still the same. And now when we are rendering to the screen, you can see that we have a transform props. We pass it the props. And then, as we said, its child must be function. So we pass it a function that takes the props, and props are accessible thanks to this in this playlist. So this way, transform props as well as this playlist are both reusable. So this solution is pretty comparable to our higher order component. So should we use this or higher order component? Now the good thing is to think about is that can we use this pattern to also mimic a higher order component composition? Then when we have two enhancers and not only one, let's take a look. Now we have a simple state. It's our former with simple state. It's not a higher order component. It's an ordinary component. It provides us with state. The only new thing is at the end it presumes its child is a function. We have a transform props, again, we've already talked about that, and this playlist that displays button and Star Wars characters. And now this really, I hope you can see it. This is really huge render function. Now you can see that we wrap the transform props inside the function, this playlist inside the function, we are passing all the props. Now just imagine if we had like 5 or 6 higher order components. This would be really huge nested function. So the components are still reusable. But in my opinion, the readability of this is worse than of higher order component composition. Because if you want to add a new enhancer, a new higher order component into higher order composition, higher order component composition, you just add a new higher order component into the compose function. It's much simpler than just to write everything down here. So if you need a complex logic for your components that can be tailored for a specific use case, higher order composition is the way to go. Now, yeah. So, at the beginning, we start with this component. We said is hardly reusable. Logic, presentation, everything in a single component. Throughout the talk, we were able to transform this to this. We have a reusable presentation components, and we have 3 reusable higher order components. Now, as I mentioned at the beginning, at Ataccama we are developing pretty large application, and we are using techniques I mentioned in this talk. So we are trying to use reusable components as much as possible, and a higher order component pattern is helping with us a lot, because we move the logic to the higher order component and let the base component takes care only for the UI. So in the end we have reusable higher order components and reusable presentational components. And then we just use the reusable presentational components through our application, and we enhance it by a single or by several higher order components depending what kind of logic we want. So we don't need to. So we are using classes basically only for higher order components that needs that class behavior. Now, cool thing is about this approach is that if you take a look at some of our components, you just check the compose method and you see all the logic we are using in our component. And if you want to add or delete logic, you just need to use the compose function. And furthermore, if you want to see all the handlers we are using in our component, you just need to check the with handlers higher order component. And all of them are here. And if you had a huge class instead of higher order composition, it will be much difficult for you to just search through the whole class and find all the logic you want. This is readable and is really more accessible for people who came to your component for the first time. So as a result, we are developing a maintainable application with reusable components that can be composed together. Now you can check the demo of this application if you want, and one.ataccama.com. So that's all from me. Now, if you want to have any suggestion, improvements, criticism, whatever, you can contact me on my email, check out my blog, and also GitHub for the code we've just seen here. And that's all from me. So thank you. And if you have any questions, you can ask them right now. Okay.